Hello everyone, in this video, which is part 2 on our series of adding rules and filters to our Cubro Packet Master Network packet brokers, we're going to be covering the same material that we looked at in the previous video, but this time we're going to be using the command line interface to accomplish those tasks. And by those tasks, I mean the basics of building our rules and our flows, getting some traffic moving across this device. So when we log into the web GUI of our Packet Master, the first thing that we see is the rule table, which gives us a nice overview of what rules are currently on the device and what rules are doing what. When we log into the command prompt of our packet master, the first thing we see is the prompt. So it's up to us to extract some information out of this. And I just mentioned real quick for this one, obviously I'm using an EX2, but these commands are applicable universal across the packet master series devices. So to see what rules are already on our device, if any, we're going to issue a cc dump-flows bridge 0 br0 command. And we'll see by our output that we, in fact, have a clean slate to start working with. There's no rules defined on this device currently. So let's start making some. And to do that, we're going to use, as it highlights up here in this helpful syntax, the cc add flow command. The first rule that we created when we were using this, using the web GUI to do this, was a simple unidirectional rule, as in one port, out another port. So that's what we'll do here. And we're going to do that. cc add flow bridge 0. And our filter matches, or the only parameter that we're using right now, is the ingress port. So in_port equals, and then simply the port number that you want to use. In our case, 1. Then we're going to type a comma. All of the parameters and the commands that we're entering here are going to be separated by commas, no spaces, just commas. And we're going to put in our priority. Now you may remember in the GUI video, in the top section of the add rule page, we had the option to set either a cookie to identify our rule or a name and description. And then below that, we also had a priority field that had a default value right in the middle of the range automatically filled in. In the CLI, we don't have the option to put a name and description in for our rules at all. We can specify a cookie, but the cookie is going to be created by default either way. So if we don't specify a cookie, we're going to get a cookie value of 0. Nothing wrong with that. You can specify it if you want. But for the priority, if we don't specify a priority, then we're not going to have a specific priority associated with the rule, which can cause some trouble down the road when we start trying to add some more complex rules. So I recommend that when creating your rules, you always specify the priority that you want the rule to have. So in this case, I'm just going to type 32,000. I think that's close enough to the middle of the range. And then actions, our output actions, which is our egress port in this case, actions equal output : 6. We enter that, and we have created our rule. So if we do a dump flows bridge 0 again, we'll see this rule and some associated information. We have our cookie value of 0 there. We have the duration, the amount of time that's elapsed since the rule was created. We have the table that this rule belongs to, which, unless you're doing some pretty crazy things in here, is always going to be table 0. We have the number of packets and bytes that have traversed the rule, our priority, and then our ingress port and our actions. The next rule that we created was an aggregation rule, and this is going to highlight yet another difference between using the GUI and the CLI. In the GUI, we were able to specify any number of ports or a range of ports in one shot for ingress ports in one shot whenever we created our rule. In the CLI, we have to specify each ingress port separately. We can't put in multiple ports or a port range as our in-port value. That's just not going to accept that syntax. So to create an aggregation rule, like in our GUI video, we had a tap attached to ports 2 and 3. We wanted to aggregate that traffic and output it to port 5. We're going to do that by doing a cc add flow bridge 0, in port equals 2, priority equals 32,000, and actions equal output : 5. And now we can use our command history here and just tap the up arrow to bring this back and swap these values out. So we'll just do our input port is 3. And I'll quickly mention here that if the only action that we're performing is outputting to a port, we can use some shorthand here and we can actually get rid of this output : thing and just say actions equal 5, and that'll work just fine. So now we do a cc dump flows bridge 0. we're going to see all of our rules, now 3 of them, and we have our traffic coming in 2, output to 5, and traffic coming in 3 is also output to 5, and that's achieving our aggregation. Now we also have our replication rule, where we take traffic from any given port and we copy out to multiple egress ports, and there's some good news with that one. So in this case, we can actually specify multiple ports in a single go. So let's say we want to take traffic in port 4, and we want to send it out ports 5 and 6. And we'll just use the shorthand version here and say actions equal 5 and 6. So here I can separate these ports by commas. I can separate any number of ports by commas, so I could add port 4 in there as well, which would be kind of a strange rule, but hey, it doesn't matter. What we can't do is we can't specify a range. So I can't say 5-6 or 4-6, but I could certainly say 4, 5, 6, and just continue specifying ports however many I wanted that way. So we'll do 5 and 6, do another dump flows, and we'll see that we've added that rule. So right there, input 4 is going out to 5 and 6. All right, and this gives me the opportunity to show, now that we have multiple rules in here, it gives me the opportunity to show a couple things. Everything that we've been doing here is reflected dynamically in the web GUI. So all the rules we just added, we see those in the web GUI just fine. You can interact with them in the web GUI the same way you would as if you created them there. So that works all well. Another thing is with the cc dump flows command, after we say bridge 0, we can actually specify a match criteria. So I could say something like, as a match criteria, import equals 3, and when I run that, it's going to return only the command that matches port 3. Now, there are certain things that I can match on, and there are certain things that I cannot match on. Like I can't match on a priority, and I can't match on actions. As nice as it would be to show all ports outputting to 5, I can't run that. In the interest of exploration, let's try something real quick. Let's see if I can grep a cc dump flows, and maybe we can solve that problem right here for the first time. So if I say grep output equals, or output 5, look at that. So we can actually return all of the flows, and we just have to use a little bit of Linux command line stuff to do so. So in this case, by using that grep command, I could also do something like priority equals 32,000, and I could show all of the rules of a certain priority value. Cool beans. I learned something on this one too. All right. Anyway, moving on. We have, moving on. Let's talk about deleting the rules. So we have 2 ways to delete rules via the command line. We have cc delete flows bridge 0. Running that command by itself is going to delete all rules in the command line, or all rules on the packet master in one shot. Much like the dump flows, we can also specify a match criteria here. So we could say import equals 3 to delete all rules that have an import matching 3, not just the one that we had. If we have multiple ones, it would delete all of them. So if you're looking to delete a specific rule, you want to try and be as specific as possible with your match criteria. But we run that and we do another dump flows. We'll see that our port where we had an import of 3 is now gone, and the other ports remain. Unfortunately, again, we cannot specify actions to delete flows on. We cannot specify things like priority, and in this case, grep isn't going to help us at all. So I'm going to clean this up by issuing a delete flows bridge 0 command, and that'll get rid of everything. So we can move on to the next rule that we created in the web GUI was a combination of aggregating traffic and replicating traffic. Of course, this is going to require multiple rules here where it wouldn't in the web GUI. So we can do a cc add flow, bridge 0, and let's say we want all traffic coming in ports 1 and 2 to go out 4, 5, and 6. I'm probably deviating from what I did before, but that's okay. So in port 2, priority equals 32,000, and then actions equal 4, 5, 6. And then we can use our command history, bring that back up, and say, what did I say, 1 and 2? All right, so do a dump flows on that. And we can see that we have all traffic coming in 1 and 2 is getting aggregated together, and a copy of that is being output to ports 4, 5, and 6. So I'm just going to clear those out again. The next one, our bidirectional rule, is going to be, again, just like in the web GUI this time, we are going to have to create two rules for the bidirectional flow of traffic. So add flow bridge 0, import, and our bidirectional traffic is going to traverse ports 1 and 2. So in port 1, priority, of course, and then actions equal output 2. Or 3. Let's change that. And then cc add flow. Actually, we can use our command history and just transpose those values. So import equals 1, output equals 2. And I should have already overwritten that rule that I previously made. Let's just check real quick. Yes. So all traffic coming in port 1 is going out port 2. All traffic coming in port 2 is going out 1, and this enables us to have bidirectional communication across those ports. Now, if we want to have all of the packets on that bidirectional link copied out to a third, fourth, or even fifth link, we just do that. I'm sure you're catching the patterns at this point. cc add flow bridge 0, import equals 1. Priority equals whatever, actions equal out to ports 2, and let's say we want to copy all of our bidirectional traffic out to port 5 as well. So 2, 5, and then just swap these values. And now we have all traffic coming in port 1 is going out 2, copied to 5. All traffic coming in 2, going out 1, copied to 5. So these are all the same things that we did in the web GUI in the last video. That's how you would accomplish these in the command line. And obviously, this is just our jumping off point for creating some more complex rule structures. But there are some more interesting commands specific to the CLI that I want to talk about before we end this video. And actually, before I even get to those, let's talk about the mod flow command, because in the web GUI, of course, we have our little buttons beside our rules in the rule table. We already saw how to delete flows from the CLI, but we didn't see how to modify them. So let's say I want to take this import equals 1, and I'm outputting to 2 and 5. Let's say I want to change that to output to 2 and 6. We would do the cc mod flows command, bridge 0, and this is going to operate on sort of match criteria, but you're also going to specify what you want to change at the same time. So you could say import equals 1, actions equal, what did we say, 2 and 6? So 2, 6. And now we have modified that rule. Likewise, or not likewise at all, actually. So let's get to those interesting commands that I was talking about that there really is no analog. Well, to a degree, there's an analog that we haven't seen at the web GUI yet, but nonetheless, let's touch on those. So I'm just going to clear these out. And 3 commands I want to talk about are the cc add flows command, this time with an S. This is an interesting command because what it allows us to do is specify a flat text file where we've already predefined a set of rules and load them all in one shot. And related very closely to this is the cc replace flows command. And so let's take a look at how those guys operate. And since we are operating on a stripped down Linux environment, we do have the vi text editor in here. So let's create a test file just called test flows in vi. And let's start defining some rules in here. So when we have a text file and we define rules, we're going to leave off the cc add flow bridge 0 part, and we're just going to define our filters and our actions. So let's say in this case, we're going to do an import 1, priority equals 32,000, and actions equal output to 2, and then an import 3, priority equals 32,000, and actions equal output 4. That should be good. Save that guy, And then if we do an ls, we can see I have my test flows text file right here. We can cat that and see the content of that. And then we can run this command. So just to show you that there is nothing up my sleeve, let's do a dump flows again to verify there are no rules on this device. cc add flows with an s, bridge 0, and then test underscore flows. And now let's do a dump flows. Not a dump underscore flows, but a dump hyphen flows. And we'll see that those rules that we specified in the text file have just been added. Now, the replace flows is very similar to this. Let's copy that test flows text file to a replace flows text file and make some alterations on that. Oh, yeah, no utility called CI. All right, so let's just say in here that I wanted to change my input equals 3 and have that go out to port 5. So we're going to change that to port 5. Let's change this to port 6, and let's add an additional rule. So input equals 4. And actions, we can have this one also go to 6. Save that. And so what happens when we run the cc replace flows command is that any flows that would, where the filter options match the new text file are going to be replaced with the commands in the text file. Anything that doesn't match that text file is just going to be left alone. So actually, what I should have done is I should have left something alone. But if we run the cc replace flows bridge 0, and actually specify our file, and we do a dump flows, we can see that all of our alterations have been made, our additional rule has been added, and everything's peachy keen. One last command that's related to these is the cc diff flows, this time without bridge 0, don't specify bridge 0. What this allows us to do is specify 2 text files that have rules defined in them and compare those and see what is similar or different between the two. So we would specify the 2 text files that we just made, and the end result is that we should see that there is actually nothing that's the same between them. So, and that's exactly the output that we get. So for all these commands and more, finally I'll leave you with the cc -- help command, and you can see that what we talked about in this video is not even the beginning of the commands that are available here, but it is a good jumping off point to get us some basic traffic moving across the device using the CLI and to start building upon these and creating more complex rule sets. So in the next video, we're going to jump back into the web GUI, and I think we're going to take a look at filtering on VLAN IDs. So until then, take care everyone and have a great day.